Good evening, Mr. Bentley. Can you hear me? Can you hear me, Mr. Bentley?
Yes, I can hear you. Can you hear me?
Yes, sir, I can hear you, but there is a delay in your voice. Sir, we cannot hear your voice. I think you have muted your mic.
Not coming on. Maybe we should go into that computer.
A lot of people are here. The people list shows them all.
Okay, maybe we should go on to that.
Wait. All we need to do is just to tell you, this is everything.
Okay, because this is the 2G one. It doesn't look like it's got the 5G one.
The 5G is not around.
No.
Try again. Go back, hover, on it. Let's ask Martin.
Ask him quickly.
Quickly.
Okay, can you hear me now?
Martin.
Well, the sound is off here.
Yeah, because Martin, I think the bandwidth is weak here because his mic is off. It says there's too many people here. So it's switching his mic off. I think if he connects to the 5G, it will be better.
Yeah, but it's just over here. It's just not exactly full.
Okay, so let's go connect to that one. Just tell him that we're going to connect to another computer.
Wait, no. You just.
Just.
When you work out, let me just.
And you can't connect him to the 5G. Because that's going to
So now it is very clear.
We're going to have to
hear your voice.
WhatsApp there to get the link. That takes longer.
So now it is very clear. Your voice is very clear. We can hear you.
Come on, where's the other one?
Participants, please bear with this. There is a problem in the computer with the speaker's computer. So he will be coming within a few minutes. Participants, please don't share your screen. Varsha, please don't share your screen. Good evening, participants. Today we are having a session in structural element. He is Mr. Bentley Stein from South Africa, and he is a structural engineer, and he developed a concrete slab system while he was doing many construction of houses, and he saw there is a need for a new technique which is called as propless system, and he used a different type of materials to do this, and he installed this with electrical plumbing services inside the that is embedded inside the slab, concrete slab itself. So he have done a lot of jobs in this, lot of consultancy work, lot of construction work, and this particular propless beam slabs are very versatile. It will give the insulation against the temperature, and it will give the insulation against the sound, and he's having a lot of experience in this field, and he had done nearly 300 meters square of slabs. He have installed a lot of cranes using this, and he have done lot of jobs, and he will be giving a brief about this particular propless slabs and concrete beams in this session. Thank you. Mr. Bentley, can you hear me? Mr. Bentley, can you hear me?
On microphone, yes.
There we go. Can you hear me now?
Yes,
Hello?
sir, we can hear you, sir.
Okay, thank you very much. Okay, thank you very much. Okay, we just need to get the third one. We just need to get the third one. All right. Can you see the screen? Can you see the screen?
Yes, sir, we can see your face.
You can see my face.
Yeah.
Can you see the Bentley beams on the screen? Can you see the Bentley beams on the screen?
No, sir, we cannot able to see it.
Okay, just give me 2 seconds.
Sir, we will share your presentation. No problem. We will share your presentation.
Okay.
Yes, wait.
Ma'am, can you share the presentation? Jyoti, ma'am.
Yes, okay, let's get it.
Okay, sir.
Okay,
I
we
will touch.
present
Yeah,
you
he is
screen.
presenting, sir. Let us wait.
Yeah, yeah.
The third one, what?
Yes, we can see the PPT. Yes, we can see the presentation. Fine, sir. Thank you.
Okay, fine. Hi, everybody. My name is Bentley Stein. I'm from South Africa, Johannesburg, and I developed this concrete slab system and called it Bentley beams. Well, I'm going to run through you with introduction. History.
Mr. Bentley, sorry for
Yes.
the interfering.
Come again?
Can you use earphone or headphone?
The phone's for my ears.
Okay, fine, no problem.
Alt locking for earphones. Okay, we'll get earphones now. We're going to run through all these particular different points. And this Bentley beams was developed with the solution construction of slabs. We span up to 9 meters. However, after 7.6 meters, we need to prop in the middle. And then from 7.6 meters, we have to throw 340 and not at 260. Casting a deck, be it in situ or precast, usually borders on cows, electricians, steel fixers, working over and around each other. This can take up to a week or even 3 weeks before casting. Then you've got to leave the props in for another 28 days. All the while costing you money. I've developed a solution to this challenge. Now, going to history and where we started this whole thing, here was a 6.2 meter slab beam, and we loaded it with 1,000 kilograms, and there was no deflection. This is the original void filler we used, which is cardboard. And here you can see a guy, this guy weighed about 80 kilograms walking on it. There was no problems. Over here, we're throwing concrete. We treated this cardboard with a waterproofing agent, but there were 2 that we didn't treat with waterproofing agents, and none of them gave any problems. And here at the bottom, you can see this was the cardboard system that we used right in the beginning. But unfortunately, it didn't close off properly at the bottom, and we changed the system and went for polystyrene. Here we're looking at the tables, and just to show you that this is for just a rib and a slab. This would be for roof, for doing a roof. And the engineers on this particular one, this is the Procon tables, and they requested 3 Y10s, 3 Y12s. We only do Y16s and R8. Up to 4.5 meters, we do 1 Y16 at the bottom and 1 Y16 on top. When we start going over 4.5 meters, we use 1 Y16 on top and 2 Y16s at the bottom. And if you look here at the bottom with rib, slab, and a wall, you can see that our system is way over-engineered, but it's the only way it works. It doesn't work by using the Y12s and the Y10s. It tends to deflect quite a bit. This is what our actual beam looks like. The only thing we changed is that this over here on top is 58 millimeters, and across here at the bottom is 64 millimeters. And that slight V shape enables it to get out of the molds a lot faster. We've also changed this measurement here, which is 150, and we changed it to 140. And this from here, which is 50, we changed to 60. We just found while working with it, we improved it and try to make it better. Here's your 2 Y16s, and there's your Y16 on top. And the gap between that Y16 and the top of the concrete is 24 millimeters now. That enables the concrete to encapsulate that Y16 and to turn it into, and to make it monolithic, so that it turns this whole thing into a monolithic structure, making it an I-beam or a H-beam as such. Now we come to the stirrups. Now there's your top steel running across there, and your two bottom steels run at the bottom there, which all get tacked on. That's welding, tacking it on with welding. And this is basically what it looks like. And over here we have the two beams. And this is placed at 620 millimeter centers. And these beams actually carry all the load. And in between here, we put the polystyrene, and then we throw concrete on top of it. This is what our beams look like. Sorry about that. This is what the beams look like. We started with 40 MPa. We graduated to 50 MPa. And finally, we settled on 65 MPa at 21 days, which gives you 45 MPa after 7 days. The results of this was less deflection, less cracking, and less vibration, because the slab tended to vibrate a little bit until it cured properly. 10 beams are cast in a mold, and we cast the beams to the sizes requested on the particular job. Here we've got polystyrene, and here you can see the polystyrene, and we're busy putting it in between the beams. Polystyrene void fillers, I'm sure you are au fait with, are manufactured from EPS to fit the space created by the two 620 beams. The thermal resistance on this, the R value is 3.7, greater than 3.7. Fire classified as B, B1, 2, H and V. Suitable for use in all industrial, residential and commercial buildings as an under roof and side cladding insulation material. Moisture, this thing is non-hydroscopic and not affected by moisture, the polystyrene. Not affected by bacteria, mold or fungi, and has no nutrient value for insects, bird or vermin. This will remain effective as an insulant for the life of the building. The polystyrene used is manufactured from recycled waste polystyrene. Here we have an installation job which was done in Louis-Trichardt. And you can see over here, on this particular job, this was 630 square meters. We started at 7 o'clock in the morning, and by 1 o'clock we'd finished installing. We went in the afternoon and we just sorted out all the few problems that there were, or if, packed all the polystyrene, etc., etc. And then we came back, well, it was lockdown then, so we came back 2 months later to pour the concrete. So here you can see them, and here we're installing with a crane, and we did this all. By 1 o'clock we were finished. And over here, we've got a job which we did for a gym, Virgin Active gym, in fact. And you can see here the beams are not propped at all. And there's your polystyrene there, and here's your mesh, which was reference 100, which we put on top. And there you can see the amount of concrete. We only put on, in this particular case, we only put on 50 millimeter concrete. And later we changed and we went to 60 millimeter concrete. This was for Virgin Active gym. People are gymming on it. They're doing weights on it. They're running and jumping down on it. And there's a lot of people in there. Here we have them throwing concrete. This was in the job that we did in Louis-Trichardt, that big job for 630 square meters. And over here we're throwing 60 millimeters of concrete. This was something that we moved up to. Here you can see he's got his stick and he walks around judging and checking that the whole slab is 60 millimeters thick. Here you can see them pouring concrete. There's no problems. I mean, here the guys are walking on the polystyrene. We don't have any problems. I just need to have a look here and see. Okay, so basically that's the beams itself. And it shows you how strong they are. Now we've moved on, and this is, it's not there. You put it on the wrong one. This is a cement mix which we've made, which sticks to the underside of the slab, the polystyrene. And all we do is we supply it in buckets. And we had a problem previously where people told us, how do you plaster the underside of the polystyrene? So we developed this plaster which you just skim on and it sticks. And it comes in 30 kilogram buckets. And it's made a hell of a difference. It sticks to cement, it sticks to rhino board, brick and polystyrene. And it's designed to reduce cracks because we put fibers in it. You can use it outside on the exterior where rhinos the particular rhino material you can't use on the outside because it's not cementitious. Desiree, it just switches off. And okay, let's go to the next one. Okay, here we've got our email address. Sorry, there's the email address. That's our website is there, bentleybeams.co.za, and that's my phone numbers. That's the office phone number, that's the work phone number. Here in the background, you can see this is an 8-meter span beam running across there. And we loaded it with 3,300 kilograms in a point load. And this has been here for about 14, 15 months already, just like this. And the deflection on this beam is about between 15 and 20 millimeters, which is allowable according to building regulations. Gentlemen, I think we've covered that. If there's any questions now's the time you can ask me the questions. Can everybody hear me?
Yes, sir, we can hear you.
Okay, has anybody got any questions they'd like to ask me?
Participants, if you have any questions, you can ask directly.
Okay, the polystyrene is not flammable. When you hold open flame to polystyrene, it burns. The moment you take the flame away, it stops. So it is definitely accepted. The likely cost per square meter is in the vicinity of 750 rand per square meter. That's everything done, excluding that. Installation, concrete, everything done. In place of polystyrene, sure. One would have to look to see what you could use. You could use lightweight cement. Although the polystyrene is stronger than the cement, you have less problems with it. Okay, any more? Okay, I don't quite understand that, but when we construct a slab, as I said before, we can do up to 9-meter spans. But if there's nothing on the end, we can do one of two things. We can use carrier beams and tee into the carrier beams, or if there is nothing else to rest it on, you can put a mullion in, or a column. Audio problem. Can everybody hear me still? Hello?
Yes, sir, we can hear you. Yes.
Okay. We have any more questions?
Participants, if you are having any questions, you can ask.
Hello, sir. What is the cost reduction or compared to the conventional methods?
What is the what?
What is the cost reduction compared to the conventional methods? Cost reduction by adopting this kind of methods in construction. Cost reduction compared to the conventional methods.
Okay. I don't think I quite understand the question because I couldn't hear it 100% correctly. Can you just type it in for me, please? And then I can see it, and then makes it easier for me to understand. But generally speaking, once we've cast the beams, and we do about 40 beams a day. Oh, the cost reduction compared to conventional methods. Well, the conventional method costs you around about 790 Rand a square meter. And we're running at about 750 Rand a square meter. The only difference is this, is our beams are more expensive on their own. And if people compare the price of our beams compared to other beams, ours is more expensive. But our savings come with installation costs, whereas other people's installation costs are 200 Rand, ours is 90. And the concrete that we pour on top for other installations, for other beams, is also again 200 Rand, and ours is 85. So when you add everything up, if you take the material at 390 Rand a square meter, and you add 400, it comes to 790. And ours comes to 750.
Anybody having any participants having doubt?
Yes, sir. My voice is audible, sir.
Hi.
Is it audible, sir?
Yes, I can hear you.
Yeah. So I'm having the doubt regarding the codal provisions. What kind of codal provisions we can use for this kind of beams? Like specifications. If different live loads, how we can change the beam sizes and all?
No, I don't make different beam sizes. I only make 200. The beam alone is 200 millimeters. The width of the beams is 114 millimeters. And the spans you can change. I mean, it depends on what you want to do. I mean, we, as I said before, we do up to 9 meters with a 340 slab, and less than up to 7.6 meters with a 260 millimeter slab. Polystyrene. Carry on.
Okay. Thank you, sir.
For different beams, how to change size. We don't really change changes. The strength and lifetime, the polystyrene, for the lifetime of the building, there is no problem with the polystyrene. We issue certificates once we finish cost. We have an engineer working us. His name is Ivan. If anybody wants to speak to him, you can WhatsApp me. I'll send you his phone number or WhatsApp number. Okay, as far as testing is concerned, we tested this product over and over plenty of times. We do still take tests, core tests. When we throw in concrete, we throw little 100 by 100 millimeter cubes, which we send off to have tested to ensure that we're always running at 45 MPa at 7 days. Okay, I will share the PPT with you at mk612@gmail.com. We've tested this system over and over again, and every job we do is 100% successful. We did test it before. We put up all beams at different spans and we loaded them. As I said, the system is stronger than what it is or what it says on Procon. And then it gets tested all the time because we do quite a lot of jobs. Huh? I had it tested by, when I did it, I had it tested by an engineer in Cape Town, Joe Rozowski. And we put up a whole lot of different sizes of beams, different spans, and we tested them all. We loaded them, checked what kind of loading rate they can take. I took the system to Professor, what was his name? Evan. To Professor at Wits University. Alec Alvin was his name. And he checked it out and he was very happy with it. In fact, he said that we are 10 times stronger than the normal ribbon block. So we've been through all the tests. We've done all the tests, all the regulations. And as long as we have engineers' approval on our system, which we got with Ivan Hollander, I've got another one, Andrew Bull. And there's quite a few other engineers that come and see me all the time to use our system. We've done in the vicinity of over 300 houses at the moment, and we've never had a problem. We've done factories, houses, we've done 9-meter spans, 8-meter spans. We're currently doing 8.1-meter span in Vereniging. The guy that's using us there, it's a bloke by the name of Gary Mann. He's used us 2 years ago with a 600 square meter job. And we've just done a 900 square meter job with him. And now we're doing another 512 square meter job with him. So it's well tested. Everybody, it works. Okay. Any other questions?
Participants, any other questions?
I think we finished.
Yes, sir. I think people have understood the concept of this propless beams and slabs.
Sir, Dyson and sir, you proceed, sir. Dyson and
Ma'am? Yes, ma'am?
you proceed with vote of thanks.
Okay, ma'am. Okay.
Please proceed with the vote of thanks.
Okay, ma'am. Thank you. Good evening to all the participants and good evening to our guest speaker, Mr. Bentley Strain from South Africa. On behalf of our EASWARI Engineering College, Department of Civil Engineering, I want to thank all of these participants and our chief guest. They have our management, EASWARI Engineering College management, have given a lot of support to conduct this webinars so that the knowledge and idea will be spread all over the people and engineers and the forthcoming students, future engineers. And this type of ideas and techniques will be disseminated to the other people also, so that everyone will be benefited. And I want to thank our faculties, I want to thank our HOD and coordinators for supporting to conduct this webinar. And once again, I want to give my immense pleasure and thanks to Mr. Bentley Stein. He have given 40 minutes of time, valuable time, as he was in a busy schedule, and he have given a brief about this new technique. I thank you, Mr. Bentley Stein. Thank you, sir.
Thank you very much. I appreciate it. I'd also like to say thank you to Desiree, who's standing next to me. You made it possible for me to do this thing. This presentation today. Thank you, Desiree. Gentlemen, thank you very much. I will be looking at franchising the business in the near future. And I definitely would like
Yes,
to get
of course.
it.
Yes, sir. Thank you. Yes, sir. Thank you.
Sure.